let's do some algebra with functions. So these functions that can be written as equations, like f of x here and g of x here, if we feed each of them an x value or a real number, it's going to do that equation to it, and it's going to spit out another real number. So I can add those two outputs. I can add and subtract, and I can do really anything that a real number can do. So let's take these two functions and create new functions from them. Let's think about this first one. I want to create the new function f plus g at the value of x. So this will be f of x plus g of x. It is the sum of the two functions. So f of x is x squared minus 3. I will then add to that g of x, which is 3x squared plus 2. So with some simplifying, how many x squareds do we have? We have 4 of them. And how many constants do we have? We have a -1. So this is the result. That's the resulting function of the function f plus the function g at a point x. Let's do the second one now. F minus g at x. By definition is f of x minus g of x. The f of x is x squared minus 3. I will then subtract g of x, 3x squared plus 2. But I want to subtract the entire g of x. So make sure to wrap that g of x in parentheses. Because otherwise, if you didn't wrap that in parentheses, you would not distribute this negative sign. So when we simplify, we've got minus 2x squareds and minus 5. So that function right there is the function f minus g for a value x. And let's keep going. F times g at x. That's f of x times g of x. That is x squared minus 3 times 3x squared plus 2. And let's go ahead and simplify this. So x squared times 3x squared is 3x to the 4th. X squared times a 2 is a plus 2x squared. Minus 3 and 3x squared gives us a minus 9x squared. And minus 3 and plus 2 gives us a minus 6. So we see we can simplify just a little bit. 3x to the 4th minus 7x squared minus 6. And finally, f divided by g at the value x. F of x divided by g of x. F of x was x squared minus 3. G of x is 3x squared plus 2. And there's really not a lot of simplification that can happen here. So we'll stop.